Good afternoon, everybody. Who was born in 1980 or later? Raise your hand. Oh, I'm not that young after all. But because if you were born after 1980, that means you have missed the 21st years of networking. And of course, the more we live, the more we lose about history, and we all forget. I was just very lucky to be born at about the beginning of computing in general, and networking in particular. I started networking in 1971 when I was asked by the French government to build a network like ARPANET. You all know ARPANET? Do you? Well, ARPANET was the first American network, which was based during research times, but it was not the first actually. It was built starting in 1968, and of course they made a lot of publications, but that didn't make it the first one. At the same time, there were three networks developed in the US using packet switching. Another one was TimeNet. TimeNet was a subsidiary of Timeshare, a service bureau company. Timeshare was smart enough to sell their service to their competitors. Their competitors had an advantage; they didn't have to build a network. On the other hand, TimeNet could make money out of its competitors and then enlarge its networks. And finally, after 5 years or 10 years, it became the major data communication system used commercially all over the world before the telecom companies had time to put up their own. And there was also a third network from a company called CITA, Société Internationale de Télécommunications Aéronautiques, mean international company for aeronautical communications, which was not used in the US because they had their own, but they were used by practically all other companies around the world. It was used mainly at the beginning of online reservation systems for airline passengers. And if I don't want to be unjust, I think the first packet communication system which I heard of was earlier than that. It was built by the Compañía Telefónica de España. It was the national telecom company in Spain. They were developing that network for carrying banking transactions between the Spanish bankers. This one is mostly ignored by everybody. Furthermore, the Spanish are usually very discreet about what they're doing. So there are very few publications on that. And after that, of course, you had more networks. You had CICLAD. I was asking, as I said, in 71, ARPANET had not been demonstrated yet. I was happy enough to be in Washington when they gave their first demonstration, and it was quite impressive. They had about 50 terminals connected to about 20 different data centers. We called that host at the time, and it was working. And they had just set up that the night before. I mean, it was ready, but it was the first time it was put together in a place where everybody could use it. Well, it was a bit geeky, of course. You had to know a lot of specific commands to make it work, but it was impressive. So after that, everybody was aware that there was a new era. Making computers talk together was really a novelty. Before that, every computer was a single unit, sort of a fortress, which was accessible by terminals and a variety of communication systems, including the telephone system. But it was also high-speed networks for companies like newspapers. It was also local systems like Internet hadn't been invented yet. So they were very differentiated kind of communications, but everything was incompatible. You could not go to talk to another system using your terminal or using a language that you knew. Everything was specific, proprietary. So the idea of building computer networks in ARPANET was to make computers compatible, not in every detail, but to allow people to use their usual terminal to connect to any other computer, which happened to be available through a communication system. But the idea was to save money. Well, that probably was the official reason. What they wanted to do is technology. They wanted to make technology progress because the cost of telephone lines were quite expensive, and the bandwidth was not satisfactory. It was not digital yet, and you had, of course, noise, and also it was again incompatible with each other. And furthermore, you might say the line typically were only used at the time there was something being communicated. I mean, you have a lot of white space, unused times, unused minutes or seconds or milliseconds on the line. So by putting things into packet, you could raise considerably the efficiency of the communication lines. But of course, to convince the people who put the budget for those projects, you have to demonstrate some kind of economy. So they say, well, they had a lot of big computers in all kinds of universities in the US that costed money, but everybody would sleep something like 6-8 hours a day. That means the East Coast were using computers, the West Coast was sleeping, and vice versa. And the rest of the world also sleeping at different times. So by making computers available all the time, they could increase the amount of work produced. This idea was also used in France to, let's say, to convince the people who put the money, mainly administration, governments, and occasionally some private companies. They wanted to actually merge database, not merge database, but allow administration to use other administration database, because it was at the time a fashion to build database, even though there was no predictable usages. It was a good idea to make that. And they thought that by sharing databases, they would, of course, save a lot of information, but also make them more consistent. That didn't happen. All the administrations are extremely jealous about their databases, and even now, it's not really possible to share database in the French administration. You have to have not only authorization, but also interpretation, how to interpret contents of the database, which are not really well defined most of the time. Now, so what did I do? First, I recruited a top-notch team of people who I knew to have a first, what is the machine to, that's it. So I had to recruit the people. It's a red one, perhaps. Let's see what happens. No, that's not it. This one? Okay. Got it? So this was the first, let's say, prediction. The network we had to build initially, connecting Paris, of course, because Paris is the best place, the biggest place at least. And then Grenoble, as you see on the southeast, and then Toulouse on the south, and then Rennes, which is in Brittany, on the west. Using telephone lines, 9.6 at the most, typically 48 kilobits per second, really slow. And we had to install, due to politics, we had a French company called CII, Compagnie Internationale de l'Informatique, and we had to use their equipment. Well, it was not worse than the others. So it was not, at least, not an idea to make a fight for that. So I selected the Mitra 15 equipment, which was the terminal concentrators and routers. And the computers were definitely heterogeneous. You had CIA computers, Siemens, IBM, Control Data, Philips, Telemechanic, and perhaps some more strange equipment. Of course, everything was incompatible. Everything was proprietary. So we had to develop some way to make them converge, to make them communicate. And the idea was to have, like ARPANET, by the way, we did not invent all the ideas. The first thing I did when I was in charge of that, besides recruiting a team, was go and visit many places in the US. I had been lucky because I had been spending 2.5 years at MIT 10 years earlier. So I knew a number of people in the US which were very happy that I visited their place. And I collected a lot of ideas, good or bad. It was easy to see what was good and also easy to see what was not sad good. So the principle was to have in every computer a sort of interfacing software, as you know, that's now called something like layer 2 or 3 for the OSI system. We call that transport station. And in the middle, to communicate, there is a packet net, which we call seagull, which is kind of insect, you know. And then we started to build that. It took us about a year to define the protocols. And about 2 years after, in other words, in 72 or 3, that's it, 1973, we were able to make a demo. Very limited demo. We had a computer in Paris area sending batch jobs to Grenoble, and which was recovering the results back to a printer in Paris. It was quite impressive for the ministries which were attending that. And we continued developing that for another year, sorry. Of course, the magic of it is not only you can use computers attached to the net, but you can also attach local nets of various kinds, whether they are just multiplexers, terminal multiplexers, or rings, or Ethernet. Ethernet, they were not yet available, but it was already available in some kind of prototypes. And of course, protocol to make the protocol was not TCP/IP. It didn't exist. It was NCP. It was sending one message at a time and waiting for the acknowledgement. I thought it was very inefficient. And furthermore, the software developed by the ARPANET was all specific. And the idea of introducing specific software in every computer, which was of different manufacturers, that couldn't work in France. Everybody would have considered that we were intermixing with somehow damaging the computer manufacturer, initial manufacturer system. So we used essentially the standard used by the various manufacturers. They all had some kind of I/O system for communicating with telephone lines. So we used that just by putting an additional layer of software to make the interface look alike in every computer. But we did not reinvent the wheel for that. And of course, we had a protocol which apparently was one of the first of its kind at the time, which was somehow inspired by HDLC, which was a standard already defined within ISO, and which was originally from IBM, but again, it was much too constraining. So we made it a little bit more flexible in order to use communication in both ways and make it sufficiently tolerant to delays for transmission. By the way, this protocol was later on adopted by the American within ARPANET, within Internet, but with slight modifications which didn't make it better anyway. The packet switching, Again, when I visited the American, they had already built ARPANET, and they were always talking about the marvelous system that never had lost a packet. It was Frank Hart, which was the propagandist for that. But after I observed what they were doing, I decided that we were not going to take their software. And they were very unhappy about that. They thought they could sell their machines to everybody. Second thing which could be accepted, their system was based on a unique network, which everybody had to connect to. So imagine the whole world, including Russia, connecting to an American system. That could be unacceptable. So the principle we adopted that it was very simple, something carries packet. It could be networks attached to each other, any number of networks hooked together, carrying a single format of packets, simplistic, no error control. Well, there were, of course, error control on every hop due to the transmission protocols, but there was no error control between the entrance and the output of the network. A lot of people were absolutely upset about that. They thought it couldn't work. We had a little bit of congestion control, as you will see, but we say we will not fragment packets. We will not try to do any sequencing. They will arrive whenever they want. There were no virtual circuits at all, simplistic, like postcards. Everything else which will be needed will be done at the host level. That means you can look at the datagram communication system. It's just a black box which carries packets. And end-to-end control is done at the host level or at the terminal level if the terminal is sufficiently intelligent, or at the level of a terminal concentrator. We also had a tricky addressing system. Of course, we had normal address, things which go out of the net, but it could be any other network address. We did not make our system proprietary. We wanted it to be able to talk to any existing system, including the ARPANET, if they wanted to. And then we had SIGAR, the OurNet, but there could be general addresses, would be, let's say, something routine, something ordinary. Plus, we could address internally the various functions within the net software were also addressable the same way as packets. So we could send messages to our internal machinery. No specific software, no specific addressing system to reach the internal guts of the packet net, and so on. That's not. We also invented a kind of thing for doing network congestion. That's always a tricky thing. In ARPANET, they did, in Internet, I should say, they did that by creating end-to-end control, not necessarily, well, it works, but it's reasonably unpredictable at times. So we thought it was in a way simpler and more pragmatic, just to put a sort of a little counter, in other words, a time limit, a speed limit, or a throughput limit on every line, and as soon as we reach a certain percentage, which seems to be critical, like 70-75%, we send an alarm message to the sender of the packet, which means practically, if you insist, you will lose packet. It worked pretty well. We made simulations of the net. From the beginning, of course, when you send not much traffic, it's totally linear, and anything that gets into it gets out. But then you reach the point where the line is beginning to be saturated, I mean too much traffic. So you start losing packets. That means the output is getting slightly lower than the input. And at some point it stops. In other words, the network is totally saturated by the input lines, so it cannot carry anything more than that. In other words, it's stabilized in a totally loaded situation, which is not blocking that way. It keeps working, but it keeps losing packets as well if you insist. So the whole thing stopped later on when we changed president. They changed also the whole politics, the whole policy they had with computing. they stopped many things which had been started. For example, they had set up a consortium between various European manufacturers, like Philips, like Plessey, like CII. Olivetti was supposed to be part of it. They abandoned that project. They abandoned also Cyclade. And finally, the American took the hand. The X-25 was adopted in Europe, and therefore there was no more way to keep going on packet switching, because the PTTs had won the mandate of making an international standard called X-25. So we had all development on packet nets were stopped in France. And that's why the Americans were very happy to be left alone, developing internet and Ethernet and all kind of things between, let's say, 1974 and 1990, when you had the web. The web was the second European invention, which completely changed the network. Because before that, you had, teletypes or something like that, IBM 350, IBM 3750, I guess, and it was very poor, very non-ergonomic at all. So we have been somewhere left in the dark and in a desert. So we did other things with my team. We were also disbanded. They changed the policy, and we had to either to move to a different place or to change activity. Somehow I maintained different activities, various pilot projects. And at some point, I was hired by another agency from the French PDT to be running courses in a higher school south of France. It was the beginning of my retirement. So at some point, I took my retirement, and I was involved in dealing with the politics of United Nations summits about let's say, networking, about essentially the effect of developing computing system on society. That was called WISES in English, the World Summit of the Information Society. So I had a lot of conferences and meetings with diplomats and so on around the world. They knew nothing about internet, but they were pretty smart people. So we discussed with them, and they understood quite quickly that the internet as it was proposed by the Americans was not really satisfactory for them. First, it was in pure ASCII English, and that's no good for 80% of the world, which uses scripts which are not strictly ASCII. Second, all the power was in the United States because the European had abandoned and the other countries had not yet started. So that was not very pleasant for them. And finally, there was a dispute about who is in charge of spam, who is in charge of content control and so on. There was no agreement on that at all. So it ended up with a sort of diplomatic agreement whereby every country could develop things by their own, but the United States kept the ability to determine what the future of internet should be, and that was ICANN. ICANN was created, as you know, in 1998, but it was after the summits. Just a little bit after the summits. Summit started in 2001 and ended up in 2005. So there was obviously, from that time, there has been a continuous, guerrilla between American, represented by ICANN, ISAC, and all kind of lobbies, and on the other hand, the rest of the world, which was not necessarily very unified, but which were not satisfied with the situation. So what I did after that is to create another company called Savoir-Faire, called OpenRoute, but the let's say, official legal name is Savoir-Faire, but the commercial name is OpenRoute. So what we do there is to diversify. In other words, the domain name system created by ICANN had a lot of restrictions, as you know them. You're in the business, so I want to tell you what's good, what's bad. You know better than I, actually. But my personal idea was that it should be more diversified. It should be open to other sources of power, other scripts, other company policies, and so on. And competition, because at the moment there is no competition. You know, practically the competition only happens at the registrar level, but not upper end, at the upper layers. And it should be more variety in the way of handling the customers, handling the tariff, and so on. So that's what we did. We introduced a new system. It can be introduced without any upheaval. We use all kinds of routes. We have our route. We use the ICANN route. We use the Arabic route, the Chinese route. In other words, it can handle a multiplicity of routes, provided, of course, the companies which operate their routes agree about that. And second, we can introduce customization. If some companies don't want to be accessible by some kind of packets or some kind of information, they may decide that it could be filtered out. That's their choice. They are not supposed to be in the public service. And each company which is making some kind of routing like we do can have its own policies, its own marketing policies. We sell, they may rent, as opposed to what ICANN is doing. We are not collecting money every year or every month. People who buy our top-level domains own their domains, so we don't have to worry about that after that. They can resell them if they want to. Now, we don't do any hosting or any maintenance. We have excellent let's say, companies which are competent for doing that. It's subcontracted. Now, what else? Well, just an example, but that's nothing new. You have .uu. In other words, you have .pirate in Germany, and even though in so-and-so in Sweden. So technically, it's nothing really new. It's just the technology which is used within the present domain name system, except we have made it open and usable by any kind of companies which want to make their own or which are not satisfied with what is offered to them. So typically, the companies or the groups of people who could be interested in that, those who are not prepared to wait for years to get a top-level domain, or which do not agree about the constraints which are put on the domain names, or which they want to use for their own internal use. Large companies, of course, all of them have access to the internet. But on the other hand, they have a lot of documents which have to be remain confidential. And the internet is not very secure for that. It's not at all secure, actually, unless they have applications which have made secure, but which is much more difficult to implement. So what they can have is an extranet, which only make their own customers, their own people, or their own, say, business relationship available, and which is, of course, not visible from the rest of the world. They can also be in different places like Africa, for example, where they have a lot of languages. Middle East, also you have Arabic languages, and some other languages which are using Arabic script, but which are not Arabic. It's quite complicated. And that is a way, is that off limits for the US Patriot Act. As you certainly know, the US government considers itself as having the possibility to request or require accessing every information which is handled or transmitted by American companies, including in foreign countries, as long as the companies are American. That, of course, is rather constraining, rather, let's say, difficult to tolerate by many countries. So what they do is they tend to develop their own system. Like the Chinese did, by the way. In 2005, the Chinese already had an internet in Chinese completely independent from ICANN. And that's, at the moment, is about 800 million users, much bigger than any other country. So that's a trend now. It's opened the system to much more tolerant and also affordable, because the cost with the present system is much too high for what it proposes, what it offers. And that's it. I'm sorry, that's not the way, that's the other way. I'm available for chit-chat.
Большое спасибо. Вопрос, такого шанса просто не будет, иначе.
So there'll be no other chance for questions. So we thank you. We thank you very much for your presentation, for what you have done. Do you use bitcoins? Bitcoins. Do you use this virtual currency, bitcoins? Can you hear me?
Bitcoins.
I don't, because I'm really bad in finance anyway. I hate handling figures which represent, I'm not sure what, actions and things like that.
Hi, my name is Sergey. I have a question. Don't you think that that running the open root system, the multiple roots, will add more complexity to the DNS administration?
The answer is yes or no. Technically, you have a lot of complexities with ICANN, which we can get rid of if you're using an independent system. The second reason is, whenever you have competition, you have more complexity, because you have to use systems which may have different policies and may be technically compatible, but they may have their own financial or commercial policy, and they have also their way of doing business, which is perhaps geared to large companies or geared to small companies in different languages and so on. So definitely there will be more complexity with more competition.
Thank you. Did you consider the implementing of DNSSEC or other mechanism of authenticity providing to multiple root system?
We have, in the system we use, we have both IPv4 and IPv6 and DNSSEC on every root server. And it certainly increases security, but not completely, because there are still leaks in the in the protocol. The DNSSEC is not end-to-end, it's stage by stage. So there's always the possibility that one of the relays is not really honest.
Thank you.
Alexander Savnin. So by its own TLD for small and medium business, unlike for ICANN. For example, can you give a price tag for .ru, .rf, .moscow in Cyrillic script and non-Cyrillic script, .kids in Cyrillic scripts? Well, just for audience to understand.
We have one tariff for companies which do not make profits. It's 200 euros plus tax. And if you're a foreign country, you may not have to pay taxes. And for that, you become an owner. You don't have to pay 200 euros per year. It's just 200 euros, bye-bye. Now, for any other companies, we assess the volume of the company, or the amount of money they can pay up to a certain maximum, perhaps I could say, let's say perhaps I would say 30,000, 50,000 as a potential acceptable price, again for sale. Now, script has no effect. You can put any script provided it exists, provided it's been coded. but it does not necessarily to be coded in Unicode or Punicode. We take every script which is acceptable by the country where it's used.
Thank you.
Yeah, пожалуйста.
Yeah, let me, a small remark. I mean, I looked at the OpenRoot and their system, and I did indeed notice that they're using DNSSEC for all the eigendomains, but for the rest, it's just a big resolver which don't really resolve a lot of other stuff. And it's not using DNSSEC. It's also known as the alternative root supplier, the Sicilian root. I mean, one of those. And but I have the way how to get there on my laptop, so in case people want to know and want to play with it, it's very easy to do.
What is the gist of the comment?
The gist of the comment is that it doesn't do DNSSEC for any of the things they claim to be an open root for.
Still don't get that, don't get it. I'm not so good in interpreting English. I speak better than I can hear.
Well, it is the open root. I mean, the IP numbers there is they do actually a resolver which runs DNSSEC, but it only does DNSSEC for the eigendomains which do DNSSEC. For the rest of the domains, they insert. They don't do DNSSEC. That's what I'm saying.
DNSSEC? No. Well, as far as I understand, DNSSEC is voluntary application, is voluntary usage. It's not necessarily mandatory. The people who don't want to develop DNSSEC don't do it.
That's what it looks like. It is impossible that you can do DNSSEC with these alternative routes because there is no trust anchor at all available for doing that.
I often heard that, some technical people tell me that it would be much too expensive for the computer. I'm not sure myself. I'm not a specialist of DNSSEC. Could you complement your...
Well, for DNSSEC, you need a trust anchor. Yes? Mm-hmm. There is no trust anchor available for the open root system, so it's impossible to do a DNSSEC for the open root system.
Well, that's everything, as soon as you have security, you have to rely on trusted partners. And I'm afraid that in the world, this problem will always exist,
Yep, I think you can continue to discuss forever, but in general, well, yep, I can remind you because it was discussed as originally the DNSSEC it's multiple. Yes, how it's implemented now? We have one.
No, it's not at all. You can implement your own trust anchor if you want to, but if you don't do it, you cannot do DNSSEC. I mean, you can have multiple trust anchors. There's no. But that's a completely different discussion. We should probably take it.
Yeah, of course. I think we can continue this discussion later, but yes.
That's something else I haven't talked about because it was not really the subject. But the future, all kind of problems we have today with the internet are based on the fact that it's 40 or 45 years old design, and therefore almost impossible to fix entirely. Have you heard of RENA?
Yes, it's all decided. Actually, that's the other question I was going to ask is, I mean, why is the open root using the old design then? I mean, they can easily do their own. I mean, can't they just do their own? That's, I mean, it's, you are exactly copying with some words what is the current internet. And the words are pretty ugly. And so what actually would be interesting now is what would you have done differently than what is available now? Because that's a really interesting question. And we can quibble about the NSEC and other stuff. But what would you have done differently? What's the principle, a different way of doing a system like the internet?
Of course, yep, thank you that you reminded about. For me, it's just as the NSEC or PK, it's just a patch for the current system. And I'm very appreciated that Louis reminded us about the history, because now we live in stereotypes that only this way is the network built now. And what's interesting, was original ideas and varieties of different types and different approaches. And still, I never reject any new crazy ideas, because I don't believe that we'll live in this model forever. And the example of experience of Louis Pouzin show us that the history is unpredictable.
Yes, it was interesting that you mentioned it, because I remember that the first computer I played with was actually one connected to TimeNet. So that's a long time ago when I was a young boy.
Thank you. Well, we need to move ahead, you know, not just for lunch, but also in the future for internet. It's an overpatch. It's an overpatch system now. I suggest that you take a look seriously at a system called RENA, which has been developed for the past 10 years, starting in the US and now getting on in Europe. There are two European Union projects on RENA, which are called, one is called IRATI, it's developed around a lab in Barcelona. The other one is Pristine. It's another lab in Ireland, but they have, of course, a number of partners in Europe, which makes every lab has about 10 partners. This is a system which brings totally new concepts, which make a computing system, a computing network, much simpler to implement. Recursive inter-network architecture.
Sergey.
I don't hear anything.
Замечательно. Добрый день, не буду никого пугать.
Hello. I'm not going to scare anyone with my poor English. Yeah. I have a question. To Monsieur Louis. Please tell me the structure of the network that you have been showing at the presentation. Was it the basis for this French project that's Melitel? I didn't hear the name of the project. Melitel? Manitel?
The one I developed? Which project?
Минитель.
Minitel. Minitel. Совершенно.
Minitel was a project whereby the telecom people, the telecom company wanted to provide every Frenchman, every citizen with a very simple terminal which could cost nothing practically because it was given away provided you use it, of course, because that was more expensive. And this terminal was able to show pictures by using only coded characters. It was a little bit crude, but artists were able to make something very attractive using landscapes with sun and shadows and things like that. And it was extremely simple to use. It was heavily financed by the telephone company. They gave a number of contracts to various subsidizers to develop applications. The major applications was the phone system, to have a phone directory, which was no longer, it was free. No, the phone directory was free only locally. Before that, you had to buy additional books. But by getting rid of the books, you could have just a simple terminal on the side of your desk, and you could have anybody's phone number quickly. And the time, for example, I was using it for many years for making reservation on airlines, on trains, buying things and like that. It's been stopped about 2 years ago. It started in 1982, I guess. Yeah.
Спасибо.
Very long life, yeah.
Есть,
In
пожалуйста,
addition-
последние два вопроса.
So 2 more questions.
I have a question, not local and technical, but maybe some global and human. When the networks, internet and another networks are explosively growth, the possibility and desire of the humans to find information, to discover it, to explore it, and to interact with each other is increased. But also increased a desire of authorities to limit them, to find some information, to limit them to interact with each other, and its technical possibilities also increased. Also in Russia, as maybe you know. So my question is, what do you think about our future? What do you think? What will win in this battle? The desire of people to find information, or desire to authorities to limit by legal or illegal manner to limit people to find information? What will win in our future? What is our future? Thank you.
Pretty worse. I think the future now is, of course, going to an era of more control, more constraining laws, and more illegal things, and so on, because it turns out that the various governments which are presently in the world, and initially it was essentially the US, but now it's many countries have governments which have recognized the power of internet, especially the power of internet to destabilize governments, or not just government, but also large companies. And that makes them worried. And they're putting up laws or just agencies or various filters to prevent people from using the internet the way they want, or to disseminate information which are not agreeable to the governments or agreeable to the lobbies which control the governments, and so on. That's true. And it probably will last a number of years. It can be also antagonized. And that's what you can see now. Since the past 3-4 years, organizations have become pretty good at setting up what they call petitions. Petitions, that means a very active cell of people make a lot of propaganda to attract voters. They send a whole information explaining what is bad. For example, a chemical thing propagated by Monsanto, or the fact that some governments are putting in jail journalists which have just reported what's happening in the country, or because they have talking about things which are considered by the religious people as something which should never be said, or whatever, you know. And that means you have a situation where a powerful lobby or a powerful government is trying to suppress the dissemination of behavior or of information. And so the counteraction, which obviously should have happened at some point, is that the citizens begin organizing themselves to try to stop that, to maintain that in acceptable limits. They may not succeed initially, and in some countries they immediately go to jail if they do it, and that's the case in your neighboring country like China, for example. I'm sure it happens too in Russia, and it also happens in France. Don't worry, we're not the best place for freedom. It doesn't happen yet in Switzerland, but probably the places where you're safer are going to somehow shrink. So I think we will have something like perhaps 10 or 15 more years to try to find some acceptable balance of power between the organization which have government or lobby power, and on the other hand, the people power, which have the internet, which is very powerful too. And when they start setting, having something like 1 million voters which vote against a particular choice of a company or choice of a government, that makes the government think about it. Because in the government you have people who are elected. Maybe not every country again. If you have a totally autocratic government, it may not work very well. But if you have people who are elected or companies which have shareholders and have their actions, their shares are, let's say, have a value in the market, well, they discovered that by having many citizens against their position, their ability to operate or the ability to make money will diminish. So they start adopting different point of view. So the petitions, for example, 3 years ago have totally killed a treaty in the US which was called SOPA. At about the same time, the same year, I think, the European killed a treaty which was to be signed between the US and Europe called ACTA. ACTA was completely totalitarian in favor of the American. And it was considered by European Commission as something very good. It was especially very good for the people who would have benefited from the treaty, but not for the citizen. So that was sent to the trash can. And at the moment we have 2 more treaties which the Americans are pushing very hard for their benefit, of course. One is TTP, Transatlantic Treaty Partnership. Another one is it's called TTIP in English and TAFTA in French. It's again a huge treaty between US and European Union and many countries around Europe, even though they're not in the Union. They say it's about 25%, 45% of the total world GNP, which is enormous. Because once if they had an agreement on that, that means it would somehow become a standard for the other country to be followed. So that's a place where citizens can act, because they can have millions of people complaining they don't want that, and that has an effect.
Thank you, Franz. Tim, short, concise.
Always. Sir, g'day. My name is Tim Denton. I come from Canada. I sit on the American Registry of Internet Numbers, and I do a bunch of things. At the simplest possible level of explanation, what is the purpose of your open net? And second part of the question, under what conditions will it or may it succeed?
The objective, as I said, as I showed it actually, is to provide for an alternative to what is on the market, which at the moment is a monopoly. And as you know, monopoly are always totally abusive about their customers. Second thing is there are companies which need something else because they want to be more, let's say, discreet in their way of operating. And they may want to use names which are not acceptable by the monopoly, or they may, or if they are small or medium companies, they may not have the money to put the hundreds of thousands of dollars which is needed to get a name from the existing ICANN and so on. Plus the fact that using their own script in their own country is very difficult. For example, it took 6 years with the ICANN just for Bulgaria to have its ability to use Cyrillic in the domain name. and so on. It's purely bureaucratic and just petty fights because people who have the power, who have the ability to block things, are not facing a competition which makes them accept, evolutions. Second thing, whether it will succeed, well, it may or it may not. But even if my company doesn't succeed, other companies which will do the same thing in a slightly variant way, because the idea is there. It's proven. It can work technically. And as you know, whenever things works, there are always people who find some way of using them.
Monsieur Pouzin, я хотел бы поблагодарить вас.
I would like to thank you for your wonderful presentation and your lecture. And so I would like just to wish you, I'd like to wish you all the best. And so I wish that when you are 85, you will continue doing what you enjoy doing. So now we're going to break for lunch, and then at the end of the event at 6:30, so we'll have a reception right there at the entrance. Yes, 6:30. Thank you. Maybe 6:30 or 7.